Hello, everyone, and thank you for your time and attention today as we discuss solutions for Quiescent current measurements in the electric and plug-in electric vehicle world. My name is Prentice Gardner. I'm a sales account manager for Accurate Technologies. On the call with us today, and we'll be presenting is Mr. Rene Bunger. He's our advocate out of Klaric, who's a product expert and their international sales manager. Along with us on the call today is Mr. Jeff Kika, who's ATI's Executive Director of Product Design. So we'll talk a little about the partnership. Klaric and Accurate Technologies entered into a partnership back in 2019. This partnership leverages the synergies between ATI's measurement and calibration competencies with Claric's competitive advantage in the high voltage sector. So what does this partnership bring to our customers? Well, we believe this partnership offers a complex measurement solutions to the industry by offering high voltage modules, high voltage breakout boxes, high voltage probes, charge monitoring solutions, and what we'll be discussing today is our Quiescent current measurement solutions. So to get us started, Mr. Bunger, he's going to present to us some technical information. Take it away, sir, whenever you're ready.
Hello, everyone. My name is Rene Bunger. I'm from Klaric, and today I would like to talk to you to energy management, which is involving voltage, current, and temperature measurement, and here especially the Quiescent current measurement, sleeping current in general. Klaric providing a lot of solutions for the car industry, especially all about energy management inside a car, especially. So we have inside modules, but you can also see we have also charging station monitor system, which can even see more. So everything which is related to energy, voltage, current measurement, this is our topic. My name is Rene Bunger. You can see I'm from Germany here. This is our building where we are located in Stuttgart. And the company Klaric already is there or on the market since 1992, so more than 32 years. We develop and produce in our headquarters in Germany, Stuttgart, and we would like to supply you the complete solution from the calibrate current sensor up to the data acquisition system and to some analyze tool. Yeah. All our sensors comes with a so-called plug and measure technology. You just plug it in and automatically the sensor is read in, all the calibration values and so on are then automatically there. You don't have to configure something, very easy to use. Also our system, the sensors and also the data acquisition system has a high resolution and high accuracy of this one. And special application, of course, we do the quiescent current, the operational and the peak current measurement. This is be done in the mobile test, so inside the car in the vehicle, but also a lot of test bench, test in the laboratory and so on. Yeah? And we are quite known for customized solution, especially when it comes also to the high voltage part of the current measurement. So when we talk about power or energy management, there is always two things we would like to measure. This is the voltage and the current signal. I have here a little example into this one. The blue line is the voltage line. And the red one is the current line, which looks completely different. And here we can see the blue line, it is a 12-volt battery or 400 volt for high voltage, doesn't matter. It's quite constant, but you can see the current is depend on something. The current is not so constant as the voltage is. We have different ways, peak current and working current and the sleeping current in this case. And with all the normal system, you have to choose a measurement range. For the voltage, it's quite easy when we have 12 or 24 or 48. Or even the high voltage batteries, you just choose, let's say, plus minus 20% more. So the range is quite easy because you can see the blue line is very stable. But for the current, this is not so easy because it is depend on the using of the devices under test. So when we have a suspension or a steering wheel with electric let's say, helper function. This is then depend on how the customer used this component. So when the road is good and the suspension don't have to do something, so maybe then the current is less. But when they have a bad road and now the electronic motors need to work a lot, so then we can see a lot of current going on. So here it's a little bit more difficult to find the right measurement range. When we expect a peak of 350 amps, and here, let's say, working current of 80 amps, we also know that the working current can go down to 5 amps or can be minus 200 amps. And later in the quiescent phase or sleeping phase of this car, the current goes down to 10 milliamps. And we would like to measure all of these. So, and even sometimes when we expect to have 350 amps, the real world show us sometimes we have more 500 amps, not expecting, or even we have less because there's a problem into this one. And then we only have a peak current of 100 amps. So how we can choose the right perfect measurement range? And here Klaric has a very nice solution for this kind of application. And this is the Klaric auto range in all our systems. What does this mean? Here is an example. When you have to choose, for instance, here, the 1000 ampere range, because you don't know what exactly will happen, you can see, when I see this page here before, the red curve is quite good. You see all the noise and ripples and all the behavior of this one. But when I choose the wrong range, it is a little bit like I zoom out. I cannot see all the details that much anymore. And therefore, I also will lose the accuracy of the system. And this means also I can see less the behavior of my devices under test. This is, of course, not so good. And now the other side, when I choose too small range, then I'm losing data because then I come in the over range and then maybe I need to do my test again and so on. So this is the problem when we measure current in this kind of situation, we don't know the current. And therefore, this is quite difficult. And thanks to the Klaric auto range function, this will change the measurement ranges automatically. So you can see this here when the current in live is high, automatic Klaric will choose the highest measurement range. And when the signal becomes lower, then automatic Klaric will change the data acquisition system to a smaller range. Even when we come to the quiescent sleeping measurement current measurement, then automatically we will choose a very small range. And then, of course, we can see this signal very precise in this case. And when I say we change the ranges, usually we do this in less than 0.3 milliseconds. So this is then quite fast, depend on the ranges. This example shows that we come from a high current here to a low current, but it goes also the other way around. When we are sleeping and we wake up the car, automatic, then it will choose a higher range when the current becomes bigger. So it works in all direction. And nevertheless, we can also measure voltage and temperature. And here is the same thing. Also in this case, when there's a smaller voltage, we can also change the ranges automatically in this case. And this is for all, it's a general feature of all our systems in this case. And when I say we change the range, I have here a little example. So we have here a current sensor with 2 milliohm. This can measure up to 525 ampere peak for a short time. The continuously current we measure, usually the working current is up to 80 amps. And I have a resolution up to 150 microamps per bit. So a very, very high resolution for this one. So you can see the biggest range is 525 amps, but automatically it will change then for the quiescent current up to 4.5 ampere range. And when I use also other sensors, in this case, we can even come lower. This is always depend what you would like to see, still the peak current or only the sleeping current in this case. And what does this mean in case of accuracy? Klaric always measure 0.1% from the value plus minus 3 bit. And the plus minus 3 bit is coming from the measurement range, and the measurement range we change automatically. So I have here a little example where we measure here with this sensor up to 525 ampere peak current. And when we measure 350 amps, we have an accuracy of around 400 milliamps, which is 0.07% from the value, quite good. But when automatically the current becomes smaller, like here 80, 20, 10 amps, 4 amps, and even 1 amp, you can see the accuracy goes then always becomes better, because 0.1% from the value, not from the range, and then plus minus 3 bit. And here, even when we would measure with this sensor of 525 amps, and we measure only 10 milliamps, the accuracy, not the resolution, the really accuracy is then 0.42 milliamps. Please remember, we still have a 525 amps sensor, in this case. So this is the accuracy of the range goes then to 0.00008%, of the measurement range. And this is really high accuracy of the whole system. And to compare this with existing products on the market, you can find easily sensors which have an accuracy of 0.1%. From 525 amps sensor means 525 milliamps accuracy. And you can see, compare this with the Klaric accuracy of, in the smallest range here, 0.42 milliamps. We are 1,244 times better than a sensor with 0.1%. And please note, our specification, 0.1%, from the value plus minus 3 bit is for both, is for the sensor and the data acquisition system. And this is a very high accuracy system. So we looking for customers, you can see this with our sensor and our data acquisition system, we looking for customer like this little kid here, which like to zoom in, would like to see exactly what's going on. Let me zoom in. What is here the problem? Because we're looking for small changes and very high accuracy in this case. So like a microscope, you zoom in and you exactly looking there what's going on in this case. So Klaric, we providing the Klaric probe with our Klaric data acquisition system, and you don't touch any of our softwares. And with this solution, you can measure the peak current, the working current, and the quiescent current in this case without any touching or changing of this all systems. Because everything is done automatically in this one. And that's a really nice system. So what is the idea of the Klaric system? First of all, we would like to provide you with the right sensors. You can see here on the top, we have different sensors for voltage, current measurement, and temperature measurement, high voltage, low voltage. Then we will supply you with the right data acquisition system. So the blue one is our low voltage system. The red one is the high voltage system in this case. And the green one can also save the data in this one. So this is also a standalone logger function in this one. And then we have the next is the Klaric charge. This is a smart battery, UPS, because when we measure the quiescent current, we don't like to get power from the battery because to have a load for the battery. So we have our own UPS in this case, and then we can supply our system with this UPS without influencing anything from the car. And we also have the charging monitor. This, just for your information, is a system where we can measure how electric car get charged, for instance, in this one. We also have our own software as the toolbox to configure this and the Klaric viewer to see the data. But mainly, you can use this to any kind of CAN or Ethernet system because we're looking for some standards. We have the normal CAN protocol in this case, so you can integrate us in all the systems you have. And for Ethernet, we're looking for XCP on Ethernet. This is also world standard and will work for many systems. And ATI Vision software, of course, support all of these. And you can integrate this system in already existing and combine it with other systems as well. And from all these things, we can do your application. When today it's a car, tomorrow a train or whatever, we have power grid applications, solar panels, wind turbine, mobile phones have the same problem. They have a battery and they would like to get the maximum out of the battery. So it's similar applications here in this case. So this is the Klaric overview. So we have our own calibrated sensor data acquisition system. You can see here the high accuracy of 0.1% from the measured value, plug and measure technology, auto range, very easy to use. We can also analyze the data inside the module. So we have a power analyzer into this one. We can calculate the power, the appearance power, power factor, cosinus phi, RMS value, frequency for AC, and so on. The work, we can calculate the charge balance. So charge balance means how much ampere hours goes into the battery, how many ampere hours come out to the battery. We have special noise filter, because when you have in this environment, there can be some electric noise, especially for high voltage cars, and we can avoid this. We have special filter function in this one. We can also change dynamically the sampling rate. So depend on some threshold, we can change then the sampling rate to faster and to lower one. First of all, to reduce the amount of data, and secondly, also the power consumption of our modules. Yeah, in general, our system has two digital outputs. One is the CAN output, and this is here so-called with the DBC file. You can just export the configuration and integrate it in any CAN module. And the second standard we have is the Ethernet one. So here we use the XCP on Ethernet protocol, A2L file. And here the digital baud rate is just faster, 100 megabit instead of the 1 megabit for CAN. But we also have standalone system, has a little USB interface, and then it saves the data additional on a USB stick if you like. So this is a kind of black box application. And also our modules are highly compact, IP65, so waterproofed in this case, and the temperature range goes from minus 40 degrees Celsius up to 120 degrees Celsius. So you can use this for many things. So here we can see the special application, the special topic today, the Quiescent current. So in a car, we have a lot of electronic systems controlled by ECUs, and safety functions, for entertainment function, for many things. There's a lot of such things today it's coming from different manufacturers. Everything works also perfectly by themselves, but when you put them together in a car, you may get some problems how they interact to each other, and therefore we have to test if everything works as expected. Also today, there's a lot of software involved into this one. You have a new software coming, a new update in this one. So the development is on the one side for new cars, which will coming soon in this case, but also for existing cars, because today you can also update the software of the car over the air. So they have now, let's say, mobile phones into the car, and over the night you can send the car a new software, and this will update this. And when the next day the customer will start the car and nothing will work because the battery is empty, because something was wrong, there can be a huge amount of person next day not be happy. So we need to test all these things before a new software, and what is the reaction to all the components of the car in this case. Usually what we choose here in this case, you can see here, we have the battery current. Of course, we have to. The battery is the important one. How much power comes out from the battery? Also, when we have the Quiescent situation, the sleeping of the car. So we have here two different sensors. We usually use the HI probe, the high current probe, and the HP probe is an P probe, means power. The HI probe can only measure current, and the HP probe can measure automatically current and voltage in this case. So here, because we have the high current, also when we start or when we use the car, we have to survive or would like to measure the high current. And with the same sensor, we can also measure the sleeping current in this case. But also customers sometimes use only the LI probe. The LI probe is the low current probe into this one. You can see below. And of course, we also have the P version out of this, the power version for measuring voltage and current. And then for the sleeping current, we have to see when the sleeping current is too high, who is guilty, who makes the problem. So we have to measure all the ECUs inside the car. And to wiring all these channels is very, very a lot of work, to be honest, because first of all, you have to find the right cables, and secondly, even when you have find the cables, you have to put all the sensors. And honestly, the car is not designed for test engineers. The car is designed to be small. And so it's sometimes very, very difficult to put, even when you have a clamp or whatever, put it over the cable. You have not the space to put it in. Yeah, so this is a big problem, and we have special product for this, because you have the fuse box of the car, and we have special fuse probes where you can remove the fuse out of the fuse box and put the sensor in, and put the fuse still in the sensor, because then it's still protected and you can measure this. And it's a very, very easy way to find out which ECU or which system create the high current for the sleeping mode. Yeah, in this case. Yeah, some customer also would like to measure exactly for this one ECU, and then we also use the LI probe, the low current probe, as well into this one. Yeah, and all these sensors you can connect to our data acquisition system. Yeah, we have the blue one for low voltage, the red one for high voltage, and here you can see also the other one is the Cord 5. This is a system which also can measure all the voltage, current, and temperature. Additional, you can order this with a display because it's a standalone version. And the standalone version means you don't know if the system works right or not right. That's why you can order this with a display, and automatic, when you put the probe in, connect the probe to your test object, you can see automatically all the values in the display. Yeah, and it also, we have here the possibility to use our smart battery, smart UPS, to power our system for up to 200 hours. Yeah, this is more than 1 week to measure all these things. Yeah, to see this. So here you can see the low voltage part into this one. We will talk now a little bit more. So first of all, Klaric have a lot of current sensor, because everything starts with the right sensor. There is some companies, they have a 1 ampere, 10, 100, and 1000 amp sensor, and Klaric has all. It's starting from 1 ampere up to 2, 3, 5, 10, 15, 20, and so on. Because accuracy, you first have to start it with the right sensor. And therefore, Klaric has a lot of solution. We built and creating our own sensor in this case. Yeah, and that's why this is a very important point. Everything starts first with the perfect sensor, and we have a lot in this case. Yeah, and we have this, the Quiescent current measurement is not only for low voltage, it's also for high voltage. Of course, also the high voltage battery, we would like to get the maximum out of this, and have the same problem. Yeah? And then you can see the blue one is the low voltage one, the red ones or orange ones are the high voltage version of this one. And here we have a look a little bit deeper to our fuse probes. So here you can see the fuse box of the car. And what you do is just put the fuse out, put the fuse into our fuse probe sensor, and then put the sensor into the position where the fuse was before, and that's it. And in 1 second, you're ready to measure. You don't have to do something. You put then the cable just in the system, and automatic, the sensor will be recognized, automatic, all the calibration values will be there, and you just start immediately the measuring. But thanks of the auto range function, you don't have to choose something. In this case, and when it's a high current, we measure the high value, and when it's a low current, we measure the low value perfectly, because of the auto range function. This is a very nice solution. Here you have some pictures to this one. There is many fuse boxes, or here in this way, there are 2 fuse boxes, one in the door side here. We can see some cables coming out, and the other one is under the hood in this one. And then you can see the cables can be also there in the engine room, let's say, because the system surviving from minus 40 degrees Celsius up to 120 degrees Celsius. But some customer also like to have the cable and put it in, and so on. So this is depend on you, how you would like to use the system. You can see here some examples. So, and here you can see all our different types and so on. We have FK1, FK2, FK3. There's so many just ask us what kind of use do you have, and we will provide you with the right solution. And we have here the ranges 5 amps, 10 amps, whatever, 40 amps, 60 amps. Yeah, we have a lot of this, I think 13 different, let's say, variant of this one. On each one you can order then in all the measurement ranges you would like to have. So that's a huge amount of sensors we can provide you, because you have to start first of all with the perfect sensor. This is already the half of the job. Yeah, in this case. Of course, we would like to measure also the current of our battery, because the battery, we would like that it's surviving long, and we would like to measure what's at the end coming out and in of this battery. Yeah, so we have here our both sensor, the high current sensor. Here the sensors you can see have a continuously current from 60 amp and the peak current of 420 amps. Yeah, but this still with a resolution of 0.12 milliamps. And this is a very, very high accuracy and resolution of this one. So even with these sensor, you can measure milliamps very, very easy. Maybe you saw my picture before the table, when also with a 525 amp sensor, we can measure 10 milliamps very precise in this case. But also, of course, we have the current sensor, and you can use the current sensor directly. You can make this battery pole sinks on it. And then you just put the battery cable away and put the sensor between, and still can connect the same cable in this case. But sometimes you don't have the space to do that. So we have also, you can see this here, the battery extension cables, very flexible cable where you can put the sensor a little bit away from the battery, because sometimes you don't have the space to install something like this. So you can see Klaric has the whole solution. We're not providing you the sensor, we're providing you extension cables, whatever you need to do this kind of application. Everything around this one. Of course, we have a voltage, also only voltage or only temperature sensors as well. And here we can see some of our systems. The multi-8 is a very often used system, has 8 inputs. You can see this, or the multi-4 has 4 inputs in this case. And each input, each connector has 2 channels, because we would like to measure the current, but also we would like to measure the voltage, because sometimes the current is depend on the voltage. Maybe the current is like this because the voltage is something. So that's why all our inputs have 2 channels. And with the 2 channels comes also 2 analog digital converter. So we don't do a multiplexing, because we're looking for high signal quality. The maximum sampling rate is here 8 kilohertz per channel. And now you can, every day, you can measure today the current, tomorrow voltage, the day after current and voltage or temperature. You just have to select what kind of output you would like to have. Is it a CAN output or is it an Ethernet output? And then this is the whole job in this case. Additional, the Cord 5 you can see here has also the log function and the display function. To see the data on this one. And here you can see what does it mean with the 2 channels. I have here 1 cable, and when I connect the current sensor, the current goes through the sensor. But I would like to measure also the voltage. So automatically 1 pin for the voltage is already connected, because it's the current measurement pin. So we just, to measure the voltage now, we just need to put you another cable out. This is the red cable that we can connect the other side for the voltage measurement. Means when the orange cable here is the plus pole where we measure the current, you connect the red wire to the minus. Or when you make the minus measurement for the current, you have to connect the red cable to the plus part of this one. And automatically then with 1 cable and 1 sensor, you can measure both. And you can measure, calculate the power and other things as well, and see maybe the voltage drop here, and that's why the current is like it is. A very nice and very easy solution. Additional, by measuring voltage and current, we can calculate the power. as well. But we also do internally other analyzers like charge balance. How many amperes hours comes in and how many amperes hours comes out. Charge the battery in this case. Or we have special anti-noise filter into this one. Or we do data reduction. So the module is not only a stupid data collector or something, it can analyze the data. You can calculate something internally into this module, and you can send the raw data out and the calculated data, or only the calculated data, as you want. Also you're very flexible in these cases. And here, additional, the Klaric has the same features like the Multi 4. We have here 4 inputs, 8 channels, but additional, it has the possibility to use to save the data on a USB stick. Of course, it can send out the data also by CAN and Ethernet, no problem. But additional, it can also save the data on the USB stick, and then we have a kind of black box mode. I can put it to the car, gets the power, it automatic measure, and it automatic records the data. And with the little display, I can check my values and see, the system measuring right. Because when it's a black box application, I cannot have a PC or whatever. So this display tells me, I look to this one and say, okay, 12 volt is okay, or 14 volt, the voltage is fine, the current looks fine, and I can see the data and I see, okay, record the data, everything works fine in this case. So also a very nice solution. And now we come with the next system. This is I call it a smart UPS or smart battery in this case. So this is a battery pack. You can decide in 3 ampere hours, 6 and 20 ampere hours, in this case. But this one also has a CAN connector into this one, because it can also measure, of course, the internal input voltage and output voltage, input current and output current, of course, and it sends also by CAN bus out the status of this internal battery. So you can see this when you are, let's say, using the ATI software, you can see the status of this battery. But now there is condition during the test where you say, when my car is running on the highway, of course, there is a big power consumption by the motors and so on. So now I would like to charge my battery. Because I don't like to take the battery in the evening out of my car and charge it over the night for the next test. You have condition into your car where you say, okay, I'm looking for the Quiescent current measurement, and when I make my test and drive the car, I can automatically charge this battery. That later, when I do this kind of test, then I need the power for this system. And this is all configurable. And this, we have 3 inputs. One is called the digital input. So this is just a voltage input, and you can decide it. Okay, when this pin has, let's say, more than 8, 15, whatever volt, you can then automatic the system get charged. When it less, the input signal is less than this voltage, it will stop to charge. So maybe you remember in the past we had the pin from the radio. When you start the car with the key, automatically one pin will start the radio, and we can do here the same. So when you start the car, we can go to the same pin automatically. Now the battery charged in this one. And when you stop in automatic, it will not charge anymore, but now it will supply the modules with the energy of the battery. Another one is the battery voltage. You can say, okay, when the voltage is more than 14, 12 or whatever, automatic you get charged into this one. And when it's less than this one, don't get charged anymore. Or you can control it by CAN message. You know it best, and you say, okay, when I send this and this CAN message on this identifier here, charge and not charge. So it's a very smart, intelligent system which is used for many customers for this kind of application. But you also, the customer use it sometimes also not only for Klaric module, also for other third-party devices as well, because they like the function and they like that it's that smart to do this one. And now you can put this all together. So first of all, we have here the Klaric battery pack, or the normal cigarette 12 volt of the car or whatever. We have the power in this case, and we have a split cable. And so the red wire and the blue wire here comes together, because the blue one is the data. Can be CAN or Ethernet in this case. And then you go to the first module, will power and have the data transmission from this system. You go to the next daisy chain, to the next system, to the next system, to the next system. Because CAN and Ethernet It's a digital bus. You can use this kind of technology. You can also see the they are clickable. You can click them together to a huge group today, put them in a big system. Tomorrow, you can have a cable between, and because you can go with the amplifier where the sensors are. And because of the high temperature range of also the data acquisition system, you can bring it all over your car. And this saves a lot of time and cost to wiring all the car. So it's a very flexible solution. Also, when you need some channels more, just ordering some more modules, put them in, connect them with a cable for power and data transmission, and it's done. Very easy. In some seconds, you're ready to go and measuring this. And when I talk about auto range, here you can see the red signal is the current comes in, and here we put a sinus on it to show you that here below the second graph is the changing of the measurement range. Always when the signal becomes around 0, of course, now it recognizes this and it will automatically change it in a smaller measurement range. And what I would like to show you in the red signal, you cannot see that we change the range. There is no steps, there is no noise, there is nothing to see. It's just a smooth signal. Klaric is doing the auto range since over 30 years, so we know how to do this. It took us some really time to create this algorithm, but it's perfect. You cannot see any influence in your signal. You just get a very perfect, smooth signal. That's a very, very nice technology in this case. Okay, other things we also do here, we can see here that, for instance, here we would like to reduce the amount of data. Let's say in the beginning, you can see this, the red signal is the current here in this case. So we sample in a slow sampling rate, because the car is in a sleeping mode. So we measuring only every second. And we can see here a sample, because we are not interesting sometimes to see the whole time that the current is 4 milliamps. And I need not to see this with 1 kilohertz for some hours. It's the same value. Why you give me all the time just the same value, that nothing changed? So you can reduce here the sampling rate. For instance, you can choose depend as you want. 1 hertz or whatever. You can choose any kind of sampling rate. And now when something happens, you can see this, there is sample. And now during this, you have a threshold, you come higher than this current. Here it's the negative current in this case. And we automatically change the sampling rate because now something happened. Now we show you the current in a high sampling rate, 1 kilohertz, whatever you can choose. In this case, an automatic, when it comes again to a kind of sleeping phase, then we continue to measure this with a slow sampling rate. Very nice technology to reduce the amount of data. Why we should show you in 1 kilohertz that nothing changed. You have a huge amount of data and no information into it. So here you can make data reduction in our modules. This is all because the module is intelligent, can do all the things automatically. In this one. And of course, we have the whole thing for high voltage, for low voltage. We have it also for high voltage, because high voltage have the same problems for the battery. Also, we would like in the sleeping phase that there is no consumption out of our high voltage battery is the same into this one. And I would like to see this. And it's the same problems, and we have also here solutions for this one as well. And the good thing is, even when you have a high voltage car, there is a low voltage section. The radio system and the safety ECUs and so on all works with 12 volt, for instance, or later with 48. In this case, you can combine this. You can make the high voltage together with the low voltage part into this one. And this is the solution here we have from Klaric. And you can connect this perfectly to the ATI hardware and software and see all your data perfectly. Thank you very much for your attention. If you have any question, please contact me, or the guys from ATI knows everything in this case.
You're doing customer vehicle diagnostics, or if you're dealing with a searching for a quiescent issue during transport, where you've got a vehicle being shipped from the manufacturing plant to the dealership or to the customer, and you're trying to find a quiescent current draw, you can simply plug in to the vehicle harness without disturbing the OEM harness for a nice clean installation.
Another great benefit for the tools is ease of use with various software platforms. Definitely Vision and CanLab are the primary source of data collecting, but you can also use other software platforms as long as it accepts ASCII files.
You know, the Claricord's got a display on top, so as soon as you plug in power and plug in the probes, immediately the device shows you so that you can verify that you're getting the right signals into the device.
Yeah, the product also has a built-in data logger. You have the ability to capture data live in the testing event with the built-in data logger, and it includes multiple formats, whether it be SCV or XLS formats.
Correct. And you know, the nice thing I found about installing this in the 2 test vehicles that we did here for the video was that as soon as I applied power to the Klaric cord and then plugged the probes in, the device immediately started collecting data right out of the box.
Nice.
You know, we're going to show you an example of some fast data acquisition, but right out of the box there was no programming necessary. It just plugged in and started collecting data, which is very nice.
Yeah, so you have the ability to capture data and the dynamic sampling speed. This helps increase the rates by capturing important moments and events in detail. You know, if you notice on the screen, it records at 1 hertz, and then when an event is triggered, it increased to 4 kilohertz to capture some quality data.
Correct. Most of us don't care about our steady state activities, right? We're more interested in transient events. You know, when does something happen? And so through the Klaric toolbox, we're able to configure either your live software, Vision as you're seeing here, or inside the Klaric cord, a dynamic sample burst, where it's nice steady state data, 1 hertz, until the trigger event occurs, and then it immediately starts updating at 4 kilohertz. And those rates are programmable by the user. And then, of course, once it's done, right, once the event has occurred, it goes back to a nice slow acquisition rate of 1 hertz again.
Nice.
The other nice thing is that you can trigger all 8 inputs off of 1 channel. So you could have multiple, up to 8 channels inside the one device, and you could have 1 channel trigger all 8 to get that dynamic sampling, or you can just leave the single input as a dynamic sample point.
Yeah, it also auto scales. That auto scaling functionality helps provide accuracy within the measuring range as you're doing your testing here.
Correct. You know, usually if you're dealing with a shunt installation, you're compromising your full range to get a specific high accuracy data sample. So you may miss or sacrifice your inrush current to focus on your quiescent currents, or you may lose quiescent current values because you're focusing on your inrush current. With the auto scaling, you choose the shunt, and then the software and the probe automatically adjust to give you the most accurate data sample, regardless of its point in the range.
Yeah, this description here is showing the green is the amperage value, and the red is the scale of the probe. Now, when installing the Klaric fuse, it's quite simple. Unplug the fuse of the circuit that you're testing, plug in the Klaric fuse, and reconnect that fuse to the actual device, the Klaric device, to maintain that circuit protection, and then begin testing. It's a quite simple setup. Now, regarding power in the system, you have a couple of options. You can use the Klaric cord to instrument, or you can use the battery power from the vehicle that's being tested, and then just connect your CAN interface tool for live monitoring.
The nice thing about having the Klaric charge is the fact that you're no longer affecting the vehicle's electrical system by powering up your instrumentation. So it's a much more realistic representation of the vehicle undisturbed by using the Klaric charge power supply.
And here's an example of Q on power as it relates to recording the data. You notice the current and the voltage change as the fuse current drops.
Yep, this is a good example of the vision software taking live data from the Klaric cord and the probes. So we get to see multiple probes overlaid so that you can see when certain events take place. This really helps you identify, not only the circuit as it's in action, right, the top graph, but you also get to see the overall battery activity, its voltage drop over time as its current, as it current fluctuates as well.
Thank you. Well, this was some very high level information regarding the Klaric tools. Is there any questions from the audience? Any more detailed questions from the audience?
I see a question here. Renee, if you could answer this for us. The picture of the probe is got very short cabling. What are the cable lengths for the various fuse probes that are available?
Yes, as you can decide it, there's two cables you can see for the fuse probes, for instance. One cable is for the high current side, I would say. The other is the red and the black ones, and the other side is then the cable to the data acquisition system. And this you can choose when you're ordering this one. So you can have, 1 to 5 meter is the normal range for this one. I don't know how many foots these are, but the guys here from ATI, they can help you perfectly into this one. So when you're ordering, you can choose here exactly the right cables in this case. For the car, this fits everything. When you already have existing probes, we also have extension cable. So the blue side, let's say the cable to the data acquisition system, we can also use extension cable. This is used by the truck guys when the distance are a little bit higher, because you have the system there and there and there and so on, and then the cables is a very important point.
Thank you, Renee. Is there any more questions?
Let's see. Oh, is it possible to have multiple, the question from the audience, is it possible to have multiple Klaric cords hooked up? And how would you define that if this is giving a CAN signal? How do we define that, that we know which module is sending information on the CAN bus?
Yes. As each module, first of all, you can have different probes connected to our different system. And then you have many systems, and you can get all the data by daisy change of the cable from one system to the other, and then you need one CAN receiver, which get the data. And how we can distinguish between the system. As a first of all, when we make a bus structure, when we use the CAN bus, each system has to get a CAN identifier. Identifier is a clear number, and each identifier can only be once into this bus. So when you have many systems, you give the first data acquisition the identifier 100, and then the next one is 101, the next 102, and so on. I think you have to give every data acquisition system this identifier and unique number in this case. When we go to the Ethernet one, of course, this is the IP address of each system, and then we can automatically see this one. In the software, we can also see then the version, the serial numbers, and all these things for documentation purpose. But then one cable goes to the CAN receiver, and then you read in all the CAN information, and you can see all the channels of all the systems. Also we have customers, they have up to 100. One customer, they nearly measure every current in sleeping current in such a car. I think they have 180 channels in one measurement, and then they can see all the sleeping current into this, because they would like to see exactly who is the problem. They have so many electric components into this one, and they would like to test all in one into this one. And this is a very easy technology. The just one and only limiter is the speed of the digital bus system. CAN bus has 1 megabit, which is fast for this one, but Ethernet is even faster than this one, and even you can have more channels, or the channels can have a higher sampling rate, depend on this situation. But you have to configure this once, and then you use it for the rest of the life, when you give every system their own CAN identifier. And one other nice thing, especially we support here together, ATI and Klaric as well, is so-called the multiplex DBC file, guys. Also when you have some, of course, we have the normal DBC file. Yeah, you put in the probe will automatically detect and recognize and scaled and whatever. Everything is perfect. But when you change this probe to another probe, of course, we have another scaling factor. So usually you create a DBC file, and when you connect a new probe, you have to create a new DBC file because a new scaling probe is now on it. And so the system doesn't recognize this. But here, Klaric and ATI and also some other companies have created so-called the multiplex DBC file. The multiplex DBC file is a very, very nice technology because it's a special DBC file from Klaric where we have all our probes into it. And what does it mean is this: we send out by CAN bus not only the data to the CAN record software or this one, we also send out what kind of probe is connected. And in this multiplex DBC file, because there are all our probes in, and we send out also what exactly probe is there, so automatic the ATI software recognize the changing of the probes. So what does this mean? You once connect to the system, you once put the CAN identifier for the first system, for the second in, give them an address, and just say auto range and select the sampling rate you would like to use. And then you create so-called this multiplex DBC file, read it in the ATI software, and then you can connect any probes during the measurement, and automatic the ATI software will recognize the changing of the probe. So you have to do nothing, just putting the probe in, automatic we send the data, but we also send the probe type into the ATI software. ATI software knows, okay, when is this probe, I need this scaling factor, when is this probe, this, and automatic it will recognize this and it will change it without any changes from your side. So once you configure this in the first time when you install the system, the first time, and after this, you just use it. Put the probes in as you would like to have it. Don't think about, is this the right one? And ATI and Klaric will handle all the rest for you, from changing the ranges or what exactly probe it is, and do I need now to reconfigure? No, this is our job. This is what we do for you, and you just have your job. And this is here, test of the car is your topic. And a very easy and very, very nice solution.
And it looks like I have one last question here on the board. The Klaric 5 has a USB drive as its recorder mechanism. Is there a specific USB drive size that Klaric recommends, or will any industrial size drive work?
No, any industrial size work. Also at least it should be more than 2 gigabytes because you would like to record the data, but I think there is not a limitation. But we also have customers, they use an hard disk, an SSD. It must not be a USB stick. It can be any kind of this one connected to the system. There is no special size and so on. But guys, please think about use a good one. Temperature range and so on for our test and so on. You have to care about this one. So also this one, we need to recognize this. But when you're ordering this, the first USB stick is already included. So there is not a need for you to go in a shop, but you can do it. If you lost it, or if you would like to have the data on this stick and you would like to have it go in your shop, buy an industrial one, to be honest. Because a good quality data safetiness is very important to you. They don't cost a lot, and just use them.
Yep, we would agree that from ATI's perspective, if a customer asked, we would definitely recommend an industrial USB drive for the range, temperature range. Okay, I don't have any more questions.
So to the audience, again, we thank you, Renee. We thank you for the presentation and your attention today. We believe ATI's and the Klaric partnership together will bring a great combined solution to be efficient and accurate and bring change to the complex industry we're working in. So if you have any questions or if we could be a resource to you in any way, please reach out to us. If you would like to demo this equipment or learn more information about it, we'll love to have a chat with you. Again, thank you for your time today and have a great day. Take care.